So let's talk about resumability. But first, I think a little bit of introduction. Hi, I'm Miško. I'm a CTO at Builder.io. I oversee the development of our product. And one of the things we care about a lot about Builder is that we want to make sure that our customers have the fastest possible e-commerce websites. And for that particular reason, we are focusing on a new kind of way of booting up your web application. And we call it resumability. And we actually even have a framework to go with it. We call it Quick. And so today, I just want to talk about the problem space a lot more than about our solutions and just kind of like dive into it. And so kind of an introduction of agenda, like we did a little bit of introduction about who I am. The thing I'm going to try to convince you in this webinar is that performance matters. Like the way when you navigate to a site, how long it takes to open up and how long it takes for the end user to interact with it. Like this actually has a huge implication. And when you kind of dive into it and you realize that performance actually has these huge implications, then the question is like, well, why are most websites slow? And the thing I'm going to try to convince you of is that, well, it's slow because there's just too much JavaScript. And I'm not saying we should abandon JavaScript, like that's not really a possibility, but we will dive into like, why is there so much JavaScript in there? And so then the next question becomes like, well, how do we get fast? Like, how do we lower the amount of JavaScript we have? And so we'll talk about this idea of resumability. And then finally, we're gonna finish it off with like talking about frameworks and which frameworks offer resumability and how you can actually apply this to your day-to-day life. So let's start at the very, very beginning, which is that I'm going to try to convince you that speed matters. And Google actually has collected a lot of statistics on this, and they have a website called web.dev where they talk about it. And you can read these details on your own, but the headlines are kind of like every 100 milliseconds faster, there's 1% more conversions. 20% faster, 10% more conversions. 850 milliseconds faster, 7% more conversions. 1 second slowness turns into 10% less users, and so on and so forth, right? And so lots of websites have kind of shown that speed matters for the end user, and it kind of makes sense, right? Like if you navigate to a site and the site is slow, the last thing you want to do is just kind of like sit there while the page loads or interacts, etc. Like the best kind of experience is the one where you navigate to a website, the website is instantaneous, you go and interact with whatever you need to do and move on. And this is even more important for like third world places where we don't have necessarily 5G or LTE, we have 3G networks, we have slow phones, etc. And so all of that actually points to like speed matters, and so we should really focus on that. And so Google knows this, and so they created this thing called Core Web Vitals. What Core Web Vitals is they basically instrument Chrome, and Chrome kind of keeps track of these metrics, which they call largest contentful paint, first input delay, cumulative layout shift, and so on. And what happens is when you navigate to a particular website with your particular network configuration and your device and so on and so forth, the Chrome measures these and then sends that information anonymously back to Google, and Google kind of aggregates this information. And what you see over here is kind of the 30-day average for your website. And because it's kind of a backwards looking, to the past rather than forward looking into, what your website is today, Google actually has two parts. So the Core Web Vitals is kind of the past. They also have something called Google Page Speed, which is basically the same exact thing, but in the lab. So in the lab, they will execute your website and they will simulate particular network conditions and particular device that they have. And then they try to guess as to what they think these metrics will be once they're released into the wild. And so Core Web Vitals is kind of the backwards looking of the actual real world usage of what people are actually getting. And Page Speed is kind of the, we're trying to guess as to what the metrics will actually be once you start to use it. And so a lot of people focus on this because this is something you can just, take a website and send to the Google, and Google will measure it for you and kind of give you the numbers. And it's a kind of a good predictor of what they think your 30-day average might be. Now, Google cares about this because when they do Google search, when you search for a particular product, if you have two websites that are identical in all other respects, Google will prefer the site that is faster because it gives a better user experience to the users, and of course, that is kind of what the users want. So speed is really something that everybody cares about. Now, given that everybody cares about, what is really fascinating is that we are really bad at it, right? Amazon, which is huge and has lots of money to throw at this particular problem, as you can see, they kind of score in the yellow. And most other e-commerce websites, they actually score pretty badly in the red. And if we all know that speed is important, and Amazon actually spends a lot of time optimizing their website, why is it that it is so hard to get good numbers? And it's kind of what we're going to talk about here today. And so if you look at top 50 websites, top 50 e-commerce websites, and I'm choosing e-commerce because all of the statistics that I showed you from the very, very beginning that shows that how slow websites translate to either more conversions, more sales, or fast websites translate to more conversion, more sales, and slow websites translate into losing your users. You would think that e-commerce websites would have lots of incentives to make sure that they have the best possible performance. And I think the incentive is there, but as you can see, we're kind of failing it as an industry, right? I don't expect you to read this. The font is kind of small, but it kind of shows that no matter which particular site you choose, you most likely end up in a red, and there's few outliers like Amazon, Staples, IKEA, that actually try their best to get really good high scores. But for the most part, it doesn't look that good. And so a natural question to ask is like, well, who's responsible for the slowness? Like, what do we have to change? And what I find interesting is that for the most part, people will say, well, your developers messed up. Only if your developers did something other than what they did, you would have a fast website. And I think that's actually not a good and healthy way to look at it, but also it is not actually where the problem is. Because if you go back here, these are e-commerce websites. They're top 50 websites. They have plenty of money. They have plenty of cash to hire the best possible developers. It's hard to argue that Amazon is not hiring the best of the best. And yet, even these companies have a hard time getting good performance metrics, right? And so I think it's kind of easy and natural for us to blame the developers, but I think the answer is a little more complicated than that. And so I don't think, if the developers really would be the problem, then you would see some websites that would have good performance and some that don't. But what we see is across the board is that we as an industry are kind of failing to get good numbers. And so if it's a systemic problem to our whole industry, then maybe the approach we're taking is something that we should reconsider. And this is kind of the webinar to talk about it, saying like, hey, could we actually do this in a different way? Why is it that we end up with this slowness, and what kind of a different approach can we do? And so I'm going to actually argue that the problem is that the framework mental model. You see, the framework sets up the mental model that the tooling and the developers have to follow, right? And if the framework says I need a particular piece of code eagerly, or I need to execute this code eagerly, there's very little that the developer or the tools can do to kind of delay the execution. And so while all frameworks kind of claim that they're the fastest and the best, etc., I think the real answer is a little more complicated. And what people don't realize is that when you sign up for a particular framework, you are really signing up for a particular mental model that goes with it. And as a developer, you actually get to have very little choice in how you kind of structure your application or how you lazy load the code, etc., because the framework's mental model is kind of imposed upon you, right? And so my argument here is that I think as an industry, we're having a hard time meeting these numbers because the mental model we are using for this particular approach is kind of the tricky one, right? But we should be kind of reconsidering. So there is a chart here that you can see that shows how much JavaScript we produced over time in terms of What is the average website, how much JavaScript an average website has? And if you look at it over the last 10 years, you see that it's steadily increasing, right? Like we have more and more JavaScript to our sites. And there are people who say like, well, we just need to simplify the whole thing and go back to how it was 10 years ago. But I think that's missing the point. Our websites today are a lot more complicated, a lot more interactive, a lot more usable than they were 10 years ago. And that is to a large part due to the amount of JavaScript we have, right? Like we have improved these things by adding more JavaScript to the problem. And so while we are improving the usability of it, we're actually making the situation worse for the startup performance. And so the question is, how do we get to the situation where we can have equally interactive, usable websites, but without forcing the JavaScript to be downloaded all eagerly at the beginning of our transaction, right? And the problem we're facing is that most of this JavaScript that you could see, most of it gets downloaded eagerly by the browser at the very, very beginning, right? So the argument is not here that to say like, oh, we just need to have less JavaScript. I think the amount of JavaScript is really a function of the complexity of the website, and there's very little we could do. I mean, the JavaScript is presumably there for a reason. It's that our current mental model forces us to download most of the JavaScript eagerly in the browser at the very beginning, and that's what creates the slow site. And so the question then becomes is not how do we get rid of the JavaScript, but like how do we move things around so that most of the JavaScript is actually lazy loaded, not at the beginning of the site, but as the user interacts with the website. Now, to convince you that JavaScript is actually the problem and that as a developer, there's actually very little you have in terms of like choices, we actually built this site called the Performance Insights. And what it does is kind of pretty straightforward. You pick a website, for example, here we have a Priceline.com as an example, and then you send it to Google PageSpeed and say, hey, do a prediction as to what do you think the core web vitals for this particular sites would be. And in this particular case, Google comes back and says, I think the answer is 36, and it gives you kind of the time to interact that number over here. And so as a developer, like what are the things we can optimize? Well, we can optimize images, we can optimize CSS, and we can optimize JavaScript. So let's try to optimize images on this particular website. And when we do that, you see that we have the same exact number. What that means is that this website has already done a fabulous job of optimizing the images, and there's very little we can do to kind of improve it, right? So notice the thing that was under our control, like images, we did the industry is already doing a good job optimizing it. And the same thing is true for CSS, right? Like we can go and we can try to optimize the CSS by removing style sheets that are unnecessary, that selectors that are not needed. And again, you get the same exact thing. You get like, hey, even if you do all this stuff, you get the same number. And again, the point here is that as an industry, we already are doing pretty good job here because it is kind of under our control. But notice what happens when you come to JavaScript. If you could just not execute JavaScript, and I'm going to go into the details more because not executing is kind of not an option. But if you could just not execute JavaScript, your website would immediately jump into the green, into the 96, and your time to interactive would be reduced, tenfold. And so JavaScript is kind of the problem here, right? And if you finally can see that all things together, it's still about the same number. And we did this basically for all the top e-commerce websites. And you can see that once you fix the JavaScript, pretty much all e-commerce websites can be in the 100 or, at least get in the green. And what this chart basically shows is that as an industry, there's some improvement we have in terms of optimizing images. We can get a little bit better, but for the most part, we're doing a good job. Same thing for CSS. We could, do a little better, but for the most part, we're doing a good job. But optimizing JavaScript, that's where the huge amount of benefit is. If we could just figure out how to ship less JavaScript to the browser, we could have sites that are way, way faster and a lot more quicker to interact with and allow for better user experience, right? Okay, so let's talk about frameworks now and how they work so that we can really talk about how we get to these large amounts of JavaScript. And so JavaScript is really comes in a form of the bundle size. And the way you get the bundle size is there's two parts to it. One is the content. This is the website you have written, right? These are your HTML that have written, your components, your templates, your content, etc., whatever you want to call it. And as you write more of this content, as you make the website more complicated, obviously the amount of bundle size is going to increase. And there's probably some ratio, which we call here as the marginal size, right? So for every, doubling of the content, maybe the M over here is, 1-to-1. I'm just guessing. Different frameworks have different number here. But you will also, increase your bundle size. And on top of that, the framework itself has a little bit of cost here. And so that's the constant size that the frameworks introduce. And as you basically increase the complexity of the site, your bundle size goes up. And you can measure this. So here is a bundle sizes for different frameworks. Basically, we created a mock application that we then compiled into a lot of different frameworks. And what we kind of notice is that, as you can see, this is the intersection. Oops, this is the intersection right here. And you can see that the B, or the constant size for different framework, has a different value here, right? So frameworks can compete on this. But as you can see, like as the amount of complexity of the site goes up, the B kind of becomes insignificant. And the whole thing is just governed by the complexity of your website. Now, different frameworks have different slopes, right? And this is kind of what the M is. Some frameworks have very little initial cost, but their slope is a little higher, as you can see in blue. Other frameworks have a little more cost, but they have a more shallow slope. In other words, they're more efficient about encoding the complexity of your website that you have. But overall, if you kind of look at it, it's pretty much a straight line, and it's pretty much all of these lines are approximately the same, right? And the issue we're having here is that as our websites are becoming more and more complicated, the amount of JavaScript we produce is just going up, right? And this is what you see in this previous graph over here, is that the reason we are kind of increasing the amount of JavaScript is because we're just our sites are just becoming more and more complicated. We're putting more behavior, more code, more content, richer content for their users. And this is turning out to be, having negative effects on the amount of JavaScript we have. And so the point I'm trying to make is that we have too much JavaScript on startup. And I'm going to make a little detour. I'm going to talk about Partytown for a second. And the second point I want to say is that as a developer, you actually have a lot less control over JavaScript than you think. Because you have to follow the rules that the framework has set up for you, and as a result, there's only so many things you can do. Okay, so let's take a little detour of Partytown. It turns out that all of the code, all the JavaScript that we send to the client, really comes into two flavors, right? It is the first-party code. This is my application that I'm building, and a third-party code, things like Google Analytics, Facebook Pixel, HubSpot, Amplitude, and so on, right? And so Google has kind of been keeping track of this thing, and they are saying that on average, there's something like 20 different scripts that people have on their site. Not as much as you would think, again, because of the way frameworks are designed. But we really have very little control over their scripts. It's hard for us to say, hey, let's just not put Google Analytics on the page because, well, Google Analytics is expensive. Well, I mean, if the business need is there, if the marketing needs this information, there's very little you can do. And so in most sites, the business need wins out. And so you have Google Analytics and so on installed on your site. So what Partytown does is it can take all your third-party scripts and move it over to a web worker. So instead of having your first-party code and your third-party scripts all competing at the application startup and fighting for the main CPU thread, we can just take all the third-party code and put it on a web worker. Now, they'll run a little slower over there, and that's fine because, they're just analytics. It doesn't actually create a slower perceived performance for the user. But the benefit is that the user's startup performance will be improved. And so Partytown is kind of a no-brainer. Like it's something that we should just always include in our site because it offloads a lot of code over to the web worker. Okay, so that's kind of a detour on Partytown. Let's get back to our main discussion. So let's build a very simple application and see what actually happens in the browser. And so the simple application we're building here is, let's just say we have a counter. So first we have our application, right? That's top level component. And in there we have a counter, and let's say the counter has a value, initial value of 1. And then we have a counter, and we have the component has some state, so we use state, and there's just a single button that when you click on it, it goes and increments the count. And of course, the whole thing has to be kind of bootstrapped, and so there's some kind of a code that does the bootstrapping. Now, in this particular example, I'm using React because React is very succinct, and so it fits well on a slide. But the same exact problem exists in all frameworks, right? So this isn't me picking on React. This is just me talking about generally about frameworks in general, and saying that no matter which framework you choose, you have a situation where you have a top level component. That component is passing some information to the child level component. That component has some state. And with its state, there is some kind of behavior attached to the component, and there is some kind of bootstrap that exists in order to get the application going, right? And so all frameworks kind of follow this paradigm. Now, all frameworks also have some form of server-side rendering, and so when the server renders this application, it returns us something like this. It says button is 1, but here is where the problem starts. This button right here, as shown here, it doesn't work on a client, right? It is inert. And the reason for that is because, well, there's no listener, right? Like, so somehow we have to attach a listener to this. And so this is the job of the framework. And so frameworks need to figure out how to find this piece of code right here, which basically has this incrementing of code, right? This is the behavior. And they need to take this behavior and attach it to the button. And the problem is that this piece of code is not something that is just exportable from top level, right? It's not something that framework can just import. Instead, in order to get a hold of this closure, the framework has to execute this counter. And in order to execute the counter has props, which means it has this initial value of 1. And so in order to get the counter executed, it has to execute my app. And the my app isn't really exported, and so really it has to go all the way to the bottom and try to re-render the application from the beginning and start with my application, which then in turn executes this code, which then passes 1 inside of the props, which then allows this code to execute, which then allows us to say, hey, there's a click listener over here, which finally gives us the closure that we can attach to the button. And once we do all that stuff, the application is ready to interact. And this is what's known in the industry as hydration, right? But the side effect of the hydration is that we have just executed essentially the whole application from the very beginning. Now, again, this is a simple, trivial application, but I'm using this as to kind of like start a conversation, right? And so to attach listeners, because listeners are closures, and these closures capture the state of the system, the whole thing is eager in the sense that, like, in order for, let's imagine this button would be add to shopping cart because we want to, we have an e-commerce website. In order to make this button interactive, the whole application essentially has to download and execute. And therein lies the crux of the problem, right? Because the more complicated we make our site, the more code downloads. And when you look at this code, there isn't a natural place where we can say, like, actually, let's just delay it. Like, if you step back for a second and you think about it, the only thing that you really, really need is just a click listener. And even then, you don't really need that eagerly. Like, you could download the click listener lazily. If you just knew that this button had a behavior attached to it that should be downloaded on click, maybe you could just execute, skip all of this execution and just download the click listener lazily. But in the current system, that is not really that easy to do. And so instead, what happens is that in order for us to recover this information about the click listener, right, we're pulling on a sweater, and the thread is just taking us through here to the parent components, the rendering, and so on and so forth. And we end up with a long thread that eventually meanders through the whole application. And so there's no easy way to lazy load our application in parts. What we end up doing is basically downloading the whole application eagerly. And this is the reason why websites are slow, because this eager download of the application is what takes both time in terms of download, but also time in terms of execution, reconciliation, attaching of listeners, and so on and so forth. And that is essentially why the framework, why that our sites are slow, because the amount of JavaScript that we are forcing to eagerly download at the beginning is just too much. Now, most frameworks do offer lazy loading capabilities, but the thing to understand about it is that we can't really lazy load counter or my application or any component here. We're really, the only kind of lazy loading capabilities that frameworks offer are for components that are currently not visible. So if a component is not visible because we're on a different route, yes, most frameworks know how to lazy load that particular thing. But in this situation, there is no way to not lazy load the counter, because the counter contains the state, and the state is needed to attach to the listener, and the listener is what needs to be placed inside of the button. And so because of that, all the pieces kind of have to be there. So you could say, like, well, let's say we do lazy loading, right? Well, you could try to lazy load the listener in something like this by pulling out the code into a separate, file. I placed it together here just for simplicity, but imagine this is a separate file, and you could say, hey, await this import and so on. That would improve the situation a little bit, but actually this closure that's on the button that does the lazy loading, that closure still has to be eagerly downloaded, right? So you're still forced to be like, hey, I have this closure because this closure closes over the count and set count. Therefore, I have to execute the counter. Therefore, I need to get the prop value. Therefore, I need to get the counter. Therefore, I need to bootstrap the whole application. And so even though you might try to lazy load certain things, you're going to realize that, hey, what you're leaving behind is still a closure that has all of the same properties as before. And while it is a little bit of an improvement because, this button is lazy loaded, you actually have a new problem now, which is that, well, the first time the user clicks on this button, it's actually delayed. There's an extra delay that exists. And so now you have to solve the problem of prefetching the code and so on and so forth. And so my point I'm trying to make here is that the existing frameworks aren't really helping in this particular situation. And the reason for that is because existing frameworks came from the kind of the mental model of like, once all the code is on the client, how do I start up the application? And the browsers don't really work that way, right? Like browsers work on this premise of like, well, most of the stuff isn't in the client, and I download the stuff as I need to. But the existing frameworks, because of the way they're designed, they force the downloading of an execution of all of this stuff eagerly, just so they can recover, the listeners and where they are. Okay, so what I call the existing frameworks replayable. And I'm going to contrast this to something what I call resumable. And the reason I call it replayable is because, again, if you go back to this example, in order for the framework to recover the information about the application, it has to rerun the same code that already ran on a server, right? Because if you assume that we have done server-side pre-rendering, and we did that in order to render this particular button over here, then the server already executed all of the code. But now, in order for the framework to recover that information, and what I mean by recover, I mean like recover the state and recover where the listeners are and recover the closures of the listeners. In order for the framework to get all this information back, the framework reruns the application. In other words, it replays, right? Redoes all the work that the server already did. Now, we have some tricks up our sleeves that, the replaying doesn't really refetch data because we can like inline the data into the HTML and so on and so forth. But for the most part, we are in this replayable world. What I mean by that is that the framework really has to redo everything that the server already did. And so let's look at it from a different point of view, and let's talk about what a resumable world would look like. But before I go into resumable world, I want to kind of go down a memory lane and talk about virtual machines. So the first time I saw a virtual machine, there was a particular thing that absolutely blew my mind. And it blew my mind for a particular reason. And this is, I think, the reason that because it's resumable, and this is the thing that we would like to bring to our frameworks. So imagine this use case. You have a virtual host machine, right? And inside of this virtual host machine, you boot up a secondary machine. And inside of the secondary machine, once you go through the boot up process, you maybe log in, maybe you navigate to a website, or you open a document or a spreadsheet, and then you start filling in the content of that spreadsheet. And at some point, you basically save that machine into a file. And once you save the machine to the file, you can take this file and send it to a different machine, maybe to your friend, and they can open this file and continue exactly where you left off. And what I mean by continue exactly where you left off, the thing that they don't have to do is they don't have to go through the boot up process, right? When they open the file in a new machine, there is no booting up of the virtual machine inside of it. It's just all there already the way it was. They don't open the application again, like let's say a spreadsheet. They don't fill in data into the spreadsheet again. When the VM opens, it already has the spreadsheet loaded. It already has the application running. It already has all the data, and you are literally just resuming where you left off. Now, this file has a second property, which is that, as of right now, I'm taking it from the server and giving it to a secondary machine, but you could make 50 copies of this file and send it to 50 other people. And people actually do this with VMs, right? Like when you create pre-create a virtual machine, maybe it's pre-created in the correct state, then you save it, and then you like distribute it to lots of customers. And so when the customer resumes the VM, they don't go, they're already in the correct state and ready to go. And because the file can essentially be copied, you can boot up as many of these copies as possible. And this is important because, web relies heavily on CDN and caching. Okay, so let's try to design a system which basically follows the same exact idea, but instead of, saving it to a file, we can save it essentially to an HTML. So the idea is that we are already doing server-side rendering. So we are already executing the application on a server. What if we were able to serialize the application into the HTML in such a way that the client can just resume where the server left off without having to re-execute any code that the server has already done, right? And that's the core principle of resumability. We want to just resume where the server has left off. So why does this matter? Well, because we kind of talked about how all existing frameworks have this linear relationship, right? Between the amount of the complexity of your site and the amount of bundle code that you generate. And because existing frameworks are replayable, they are forced to download more and more code as your application becomes more and more complicated. Whereas if you have a resumable system, you can delay all of that code until later, right? Your startup of the application doesn't require any existing code. As a matter of fact, you don't need to execute anything until the user actually starts to interact with the website. And you might think that like, oh, but the first interaction is going to be very, very slow. Actually, no, because you're resuming and you're just continuing where the server left off, you're essentially skipping the boot up process, right? So while booting up a VM machine inside of your host machine is kind of slow because you have to go through a boot up process, and you can think of hydration as a form of a boot up process, the resumability is instant, right? When you open up the virtual machine for the second time when it's already booted and there's already an application running, you're not paying the cost of boot up, opening the application, etc. You're just literally continuing where the server left off. And so resumability allows us to essentially get rid of this term. It makes it flat. It basically says it doesn't matter how complicated your website is. The only thing you're really paying for is some initial cost of the framework, and then everything else can be lazy loaded later. So the way hydration, the existing kind of replayable systems work is they download all the code at the very, very beginning, and then execute kind of the replay the code or boot up the website. And then once the application is booted up, it can just run. Whereas resumable systems basically say, I don't need all this code. I don't need to download all of it. And it's only when the user performs an interaction do I have to download some of the code. Notice how you start way lower than here. And then every time a user interacts in a particular way, more and more code gets downloaded, right? So these red lines are basically user interaction, and so on and so forth. And even if you interact with everything on a page, you will still have less code than you had at the very top. And that's because a lot of code in an application is code that only executes once. And because that code already executed on a server, we actually never have to download it to the client. A perfect example of that is, for example, there's lots of what we call dumb components that are used for the layout of the site, but aren't actually used once the site is kind of laid out. And so a resumable application has this property that you start with a lot less JavaScript. That JavaScript execution can be delayed until the first interaction. Each time there is an interaction, the amount of JavaScript you're executing is just a tiny fraction. Yes, over time, you approach the same amount of JavaScript as you have in the existing application, but you never actually reach it because many components are just static. And so you end up with a much kind of a shallower thing that is proportional to the complexity of how a user interacts with the site, rather than downloading all of the complexity at the very, very beginning. Okay, so as developers, we kind of decided that we really like the component development model, right? We want to build our sites in terms of components. And for good reason. Like it's a very friendly model. It's the thing that we love. It's been shown to be super useful. And so I think it's the way to build sites, is using the component model. The thing is that we need to have tools to help us lazy load this thing. As of stands right now, right, these components are tightly bound together, right? Like where my application has a reference to counter has a reference to the button, which in turn has a closure to set count, which means in order to create the set count, you need to have the state. In order to create the state, you need the proper value. In order to have the value, you need to have this thing. And in order to have all this thing together, you have to have a boot up process, right? And so there is this hidden interdependencies that make it hard for us to kind of break the thing up into pieces. And so I think this is a place where frameworks should help. So here is an example of what a resumable framework might look like. I'm not saying this is necessarily the way to solve it, just kind of for the purposes of kind of explaining it. So the original server-side content just contained button and contained one inside of it and nothing else. In other words, when we originally rendered our HTML, a lot of information was lost. And then because the information is lost, the framework has to recover the information by downloading and re-executing basically all the components that are on the page. But because we want to be lazy, we need to kind of save this information. And so what we need to basically say is that, hey, by the way, from here to here, actually there's a component here. And this component, if you need to re-render it, can be downloaded at this particular location. And because components have state, there is this bracket 0 that says like, oh, by the way, the state associated with the component can be found inside of the serialized state of the system, and it's can be found at the first location, right, the location 0. Similarly, we say that we have a button. We also serialize the fact that there's a listener over here. That listener can be found at a particular URL, which exports a particular symbol. And because it's a closure, it closes over the state of the system. So again, we say like, oh, to recover the state, you need to go and grab the state over here, which is at this location. And the end result is that this serialized format, and again, this is just an example of the format, it's not necessarily how we kind of do things, contains sufficient amount of information so that the framework can reason about the system without having to download any code. So in this particular case, the framework can look at this and say, aha, there is a click listener. Therefore, I can set up a click listener, but I don't need to actually download this code until after the user actually clicks on it. Now, if you contrast this to the existing systems really download all the code eagerly to kind of be able to attach everything. But even though you have a page, you might have hundreds of click listeners on a page. The user can't click on them all at once. That's just not possible, right? There's only a small subsection of the actual listeners that you could possibly interact with. And so by serializing that information in this format, the framework gets to understand that there is a click listener, it can set up a click listener, but actually not download any code until this actually happens. Similarly, the framework can understand that there is a state associated with it, and it knows what code to download and what state to recover if it has to, without doing any necessary stuff of work. Now, the problem is the code that the user has written has to be written in a slightly different way. But we already said that we like our component model and we don't want to change how we do it. And so what we need tooling that can rearrange the code for us for free. As a developer, I want to write this or some form of this that that's useful for you. But basically, I don't want to think about lazy loaded boundaries, listeners, state management, and all of the things that go on. I just want to write code and behavior. And so some piece of code needs to go, some piece of code needs to go and rearrange the code by pulling things out into pieces and leaving behind basically lazy loaded references. So in this particular case, if somebody has to re-render my app refers to the counter. But I don't want to have to be eagerly downloading the counter, right? Instead, now counter has to be rewritten in basically saying, if you need the counter, you can download it here. But if you re-render my application and none of the values of the counter change, then you know that you don't have to go and descend into the counter. And so you can save yourself download and execution time by skipping that particular step. But you can only do that if you can reason about the system. So having some kind of a compile time step that's automatic, that the developer doesn't have to think about, that takes the code and breaks it up into chunks. So in this case, the counter gets broken up into chunk, and the counter click reference also gets broken out, so that we basically say, oh, by the way, there is a click listener here, and this click listener, you will need to download this code and execute this function, and it has this state associated with it, because these are the methods, right, that are over here. What this allows the system to do is to say, aha, when you click on this button, I will go download just this chunk, just this click method. This click method has some state information that has to be passed into it. I know that state information from here, so I can recover it, that it's currently the state is 1, invoke this method, and then have this method go and update the set count, which in turn says, aha, well, the set count is associated with it, which has other state that I have to recover, and then I can execute this particular case. Now in here, we only have one component, and so we ended up downloading all of it, but you can see that if you have a complicated application that has lots and lots of different parts to it, this kind of strategy allows you to significantly reduce the amount of code that has to be downloaded to the client. So to kind of put these two things in perspective, right? Both systems start with server-side rendering content. Both systems have to do some kind of bootstrapping. The problem is the existing systems, which I call replayable, they force you to download all of the code at this point. And this code has to be downloaded and executed so that we can produce a rendering world of this, so that we can recover the listeners. And once the listeners are recovered and attached, we can be interactive, right? The resumable approach instead saves more information into the server-side rendering. There is a bootstrap, which is super tiny. And this allows us to bypass all of this information and go directly into the interaction. And it's only when we interact with the application do we go and download just the code necessary for this interaction, which then allows us to update just the necessary state re-render just the specific components affected by this particular thing, and go back to applying for next interaction. And this loop, yes, at each point, we can download more code, but we're not downloading a big fat arrow as shown over here. Instead, we're downloading small arrows over time, right? And this is what's shown over here, is that as you interact with the page, you are increasing the amount of code that you are using, but it's not all up front. It's spread across time and allows the user to have a very good initial startup performance and then use it as necessary. So there's lots of existing frameworks out there, and most of the existing frameworks actually fall into the replayable category. But there's new breed of frameworks out there, which are the resumable frameworks. Quick, the ones we're working on, is kind of what we think is the best candidate as of right now, but there are others. Google has an internal framework called Wiz, which runs Google Search, Google Photos, and so on. Because it's internal, you can't use it, but Google has been using this strategy for many years with wonderful results. If you look at Google Search, it's hard to argue that Google Search is slow. And it is because of this resumability property that the search is basically so fast in interaction. Marco, which is part of eBay, is working on a new version of Marco, which they call version 6, which will have resumability properties. This is not out yet, but it is something that is being worked on. And of course, Quick is the framework we work on, is almost in beta, but it is already in a state where people are already using it in production and achieving these kind of benefits. My prediction is that over time, you will see more and more frameworks in this category. And the reason for that is because, as we said, like the only way to achieve better performance is to have less JavaScript at startup. And the only way to have less JavaScript at startup is to, well, make the frameworks resumable, like have the way for the framework to be able to reason about your application without eagerly downloading all of the existing code. Now, what's interesting, I think, is that all frameworks claim that they are fast. But I think there are two different kinds of fast that we should look at. There is the runtime performance, and then there's a startup performance. And so I'm sure many of you have seen these benchmarks that compare different frameworks and their performance. But this is what I would call is runtime performance. So a typical use case here is that we're creating 1,000 new rows into the system. And the thing to understand about these benchmarks is that they run once all of the JavaScript is downloaded. The jitter has already executed, and so you're running in a warmed up state where like most of the application code has been converted into a compiled code rather than interpreted mode. They are very much focused on the DOM update speed versus the actual user latency. And they completely basically ignore the startup performance. And I'm not saying these benchmarks are not applicable or useful, but it is not the problem we have as an industry, right? The problem we have as an industry is that I will navigate to a website and I want to push a button that says add to the shopping cart. And so I am inserting, your shopping cart on the left-hand side or right-hand side of the page has 0 items in it. And now you're transitioning from 0 to 1 item. Having benchmarks that show that how fast you are at inserting 1,000 rows, like it's nice, but it's not actually reflective for vast majority of the websites. And I'm actually going to go on and say, like, actually, it doesn't matter which framework you choose. They're all plenty fast in terms of rendering. When people talk about startup, application performance, they're usually talking about a startup performance. And startup performance is a different thing from the actual runtime performance. And so, yes, we're obsessing about how fast we can render and insert new rows. It's important, but it's not actually the thing that most people run into in the real world. And so I think it's useful to actually have a new set of benchmarks, ones that specifically talk about startup performance. And we kind of started working on this set of benchmarks. And so this is a simple to-do application. And then you can see how, time to interactive, first contentful pane, total blocking time, the eager amount of JavaScript that has to be downloaded in order to get the page going, and a total amount of kilobytes in order for this particular page. And you can see how we have Quick, Marco, Astro is another framework that kind of is focusing on it. As you can see, as you go down the list, different frameworks optimize different things. The thing that Quick is really trying to do is say, hey, let's have best possible numbers here. Let's be super, let's download the least amount of JavaScript we possibly can, and then download all of it as you go. And so you can see that time to interactive for these frameworks increases over time, and it's really, time to interactive is just really a proxy for saying how much JavaScript you have to execute, right? The reason why a particular framework like Quick, Marco, or Astro are faster than like some of these frameworks on the end, it really just comes down to not that they're more efficient about the way they execute, it's just they have less JavaScript to execute. And so they're fast because, well, they just do less at the very, very beginning. And so the other thing to look at is the amount of eager JavaScript, right? And you can see this green bar over here versus, some other frameworks that kind of force you to download all of the JavaScript up front. And also the total number of JavaScript equally as well. Anyway, so that brings us back towards the question and answer session. So I will pause here and see what. What is it? Okay, so first question is, what is it that Quick is doing better than Marco or Astro to get a better time to interactive? Right, so that's a very good question. So let's go back to the chart again. And really what this chart really comes down to is the amount of JavaScript, right? If you have a lot of JavaScript, you can be clever about the way you execute the JavaScript, or you could just not execute the JavaScript, right? Nothing beats the fact when you don't have to do anything, right? So Quick is fast, not because it's clever in the way it executes the JavaScript, but because it just simply doesn't execute any JavaScript, right? So Quick's cleverness comes from the fact that Quick can serialize the application into the HTML and make it resumable. And because of that, it can delay all of the necessary JavaScript until later. And so this is what gives Quick its magical properties with respect to time to interactive, right? Because Quick is basically as close to a static HTML page as you can get. But the caveat is that Quick knows how to turn that static page into a dynamic page if it needs to be. Whereas all of the other frameworks, as of right now, basically have the other problem, which is they eagerly download all of the code. Now, if you look at Marco, the reason why Marco is slightly slower than Quick is because Marco, as of right now, first of all, Marco 6 is not out, so they don't have resumability. Instead, what they do is they have a compiler that is really, really good at looking at the code and saying, actually, this piece of JavaScript is unneeded on the client. And so they're very good at pruning the amount of JavaScript that is sent to the client, but they still have to download some of the JavaScript, right? And so I think if Marco version 6 comes out where they have true resumability, I would expect that Quick and Marco would be pretty much at the same level going forward. But already, like, keep in mind that like what we're kind of splitting hairs. So first of all, this is a 2D applications, which is a relatively small application. I would expect that as the application gets more complicated, Quick would have more of an advantage because it really just is about resumability. Whereas as of right now, Marco still is very good at tree shaking, but once the application gets more complicated, clearly less stuff could be tree shaken. But with Marco 6 and resumability, I expect to be basically on par. Other questions? Is Quick ready enough for production? So our plan is to have a beta within the next couple of weeks. Basically, the only thing that is keeping us from beta as of right now is we need to update a whole bunch of documentation. I think it would be unfair to declare something beta when some of our documentation is a little bit out of date. But as far as the APIs, we are very happy where we ended up with in terms of APIs, and we've been using it in some production websites, and it has been working very well. So expect beta in the next few weeks, and then we'll go from there. Okay. Is there a way for existing frameworks like React and Angular to adopt resumable mental model? That is a very good question. I don't know the answer to that question. It is the problem is that you require to have a kind of a compiler that can go and break up your existing application into pieces, because without the compiler, you can't lazy load in chunks, and you end up lazy loading the whole application basically all at once. And while that is an improvement, it doesn't actually solve the problem fully. The hard part is that when you break up these applications, so if I go into an example of how this is done here, where is this code? Right, yes, you can see the breaking up here. Certain things you can't pass through over here. So this is a serialization boundary, and this serialization boundary is of saying like, oh, before it would be fine to pass in, I don't know, a function across this or something like that. It turns out that the framework needs to know how to serialize all of these things. And so the kinds of things that you can pass through are kind of diminished. So you can't just take an existing application, convert it over or break it up into pieces and expect it to just kind of work. There are some constraints. So how far existing frameworks can basically push this, I think it remains to be seen. And really only trying will be able to answer that. Okay, next question is, can web components be used inside a framework like Qwik? Yes, they can, but again, web components have the problem that they need, in order for them to become interactive, they have to download and execute your JavaScript code eagerly, because without executing the JavaScript code eagerly, the web components do not know what listeners are and where they are, and therefore the web component would just be static. So in order to use web components, you really have to solve two problems. One is you need to serialize all of the components on a server into HTML. And I believe web components have some serialization strategy. I'm not an expert at it. And the second thing is you need to be basically be able to eagerly bootstrap these particular components, which in a way kind of goes against resumability. The question then becomes is like, can you somehow make a bridge between Qwik and web components so that these things can be lazy loadable? And I think that such a bridge could in theory be built, but we haven't really explored that option just yet. These were all excellent questions. Do we have more? All right, oh, more questions are coming in. Is there an edge case where resumability would not work? It's a good question. The way I kind of look at resumability is that frameworks that are resumable, such as Qwik, really can do just about anything that all existing frameworks can do, right? It's not like that a particular, if you have an existing use case for a application and it's served by one of the existing frameworks well, then it should also be served well by resumable frameworks. Like in that sense, there is no difference. Now, obviously, there are use cases which are not necessarily best fit for existing frameworks. So for example, if you wanted to build a video game, a video game is probably not the thing to build in existing application frameworks that we have, but it's a different use case, right? But as far as existing use cases that are well covered by existing frameworks, in that sense, resumable frameworks also would be a good fit. The only problem or rather the only thing to kind of think about when it comes to resumability is really the serializability of the data, right? The resumable frameworks have an added constraint that you have to make sure that your data is serializable. And in general, this is kind of, I don't want to say solves problem, but you kind of already have this problem, right? Because when you are running pre-rendering code on a server and then resuming the code on the client, you already have to deal with some form of resumability, some form of serialization and then deserialization. So I would say that this problem already exists. It's just that this problem now is you're kind of forced to deal with it on every single resumability boundary. So there is a difference the way you build an application, but there shouldn't be a difference in the kind of applications that you can build. Let's see. So this is more of a comment that this framework, is it next level of server-side rendering and performance? Yeah, so we haven't really talked about a lot of different tricks we could do on a server side and how it kind of fit in. But I think all resumable frameworks, because they have this property that they can serialize themselves in HTML and then resume essentially from the HTML. In other words, HTML contains all of the information necessary to continue execution of the application. One of the nice property of resumable frameworks is they lend themselves extremely well to micro front ends. And of course, we haven't talked about it, and this is way beyond the scope of this webinar. But micro front ends basically allow you to make the page composable. And this is especially important for for personalized content. So imagine you come to something like Amazon, and Amazon needs to say like, hey, Miško, you have 5 items in the shopping cart. That means that content cannot be cached in a CDN. But a large part of the page can be. So for example, Amazon knows that I like to do 3D printing, and so maybe they'll show me a hero image with a 3D printer saying like, hey, look, these 3D printers are on sale, or these filaments are on sale. That can be cached in the CDN, that subsection of the page. And I'm not the only one who likes 3D printers, and so there's lots of other people that can serve this up too. And so because everything is in the HTML, you can break your application up into smaller subsections, which is essentially what micro front ends are. And then each subsection can be served either fully rendered, like in the case of my name and how many items I have in the shopping cart, or it can just be returned from the cache. And so you can get a very good server-side performance because you get this composability for free out of resumable frameworks. But that's probably a discussion for another webinar. All right. I don't see any more questions, and we're kind of up on time as well. So, Bree, what's the next step here? Or do we just say goodbye?